Hello guys, welcome to Staad tutorials. In this session I will be discussing about few steel trusses which are inclined as shown in the figure. So coming to this inclined members, it is a little difficult to draw. However, we will see it. Start Staad Pro, select new project, select truss, give it some name and units are foot and pounds. I can see in the figure feet and pounds. Select next, select finish. Now that you have a grid, just edit the grid. Let us set it to 25 by 25. First we'll draw this beam, so draw this beam. Fine. Now we'll draw this angle 4 feet plus 4 feet at some distance, 4 feet and 4 feet. Now I select escape. Now we need a angle of 30 degrees, an angle member at angle of 30 degrees. So coming to drawing angle members, we have a little difficulty when we give a skew of 30 degrees in x direction, since the angle is in x direction 30 degrees, and when we draw 16 feet it exactly counts as horizontal 16 feet, and this distance becomes something 19 point something. Whereas coming to 60 degrees, if we draw 8 feet it doubles to 16 feet. So in this session I will show you how to draw with respect to 60 degrees. So as you can see, this angle is 60 degrees with respect to y, but it is minus 60 when compared to the axis. Before that we will be doing a little shifting. We need to move this node point to exactly origin so as to incline the grid. So we will select all the members, select move members in y direction -2. Since they have moved, now you can go to edit, select -60 degrees and select OK. Now it is inclined exactly 60 degrees from y axis and 30 degrees from x axis. So now you can draw 16 feet. So when we skew 60 degrees angle, the distance gets doubled. So if you draw 8 feet here, it goes double, increases to 16 feet when we go to normal. So this is 16 feet. You can even view in dimensions, so you can see it. Now that you have 60 degrees, now we move this node to origin in order to have another inclination. So this is 13.856 and 8. So we select all the members, select geometry, select move member, give minus 13.856 and -8, since we need to move it in backward negative direction. Now select OK. Yes, yes. So it gets to origin, and as per figure you can see that this angle is 53 degrees. It implies that we have this side also angle 53 degrees with respect to vertical, and this side we have positive. It means we go to edit and select positive 53 degrees, select OK. Now we draw from origin to the end point, and then we select edit and 0. Now as you can see, this is our node point which should be exactly at the origin. So we select the node point, see the coordinates, it's 13 point minus 13.856 and minus 10. So we need to give plus 13.856 and plus 10 in order to move to the origin. So we select the entire structure, go to geometry, select move, plus 13.856 and plus 10. As you can see, the members got moved. Now we can switch off the grid, and since this is a full member, we need to delete the extra. So we just select the members, go to geometry, select intersect members, and now we delete this extra member. Well, we need a beam as a whole, single beam. So we go to geometry and select the merge. We select merge members, we merge the whole beam. As you can see, now we need a beam from here to here, as you can see in the figure. So let us go to geometry, select add beam, point to point, and add the beam. Now that we are done with the figure, we go to general, select define, assign profile, angle and beam. Then we go to circle, select 0.333 feet, which will be cable. As shown in the figure, this is the cable and these are angle parts and this is beam. So we select the cable, assigned to the cable, then coming to beam, we select the beam, assigned to the beam, then coming to angle, we select angles and assign to the selected angles. Then we go to support. As shown in the figure, we have supports at exactly this point, which is a pinned support. So we create pinned support and assign pinned support. Then we go to loads, select load case details, nodal loads. Let us see, it's 12,000 at 8,000 minus 8,000 pounds minus 12,000 pounds. Now assigning the loads. Once you have assigned the loads, you can scale them. You can see. Then go to design tab, select first is code, then go to command, select check code and take off. Now assign check code to the whole structure as well as steel takeoff. Then go to analysis. First select by specification all failed beams. You can see this is a failed beam, so we once again go to design tab, give command select and take off, then assign those commands, both select and take off, to the entire structure. Now we analyze once again. Now you can see that there will be no failed beams. We can go to post processing, and view the deflection occurs as you can see the deflection is downwards. So it occurs displacement is in downwards direction. You can see the reactions and reports can be obtained as usual. Then we go to the next problem as shown in the figure. Well, you can see this is the next problem in the figure. Let us do it. Select truss, give name, foots and pounds. Now first we'll be drawing is this beam. Before that we'll edit these to 20 by 20. Well, here is our beam, and we'll move this beam 2 feet downward. So you can see it has moved 2 feet downward, and now we can draw from here an inclined angle as shown in the figure, as inclined to 60 degrees, which means minus 60 to y-axis. Well, you are given minus 60 and this is 60 degrees. So you can see 8 feet and 4 feet. So we'll be drawing first 4 feet. And then 2 feet, and now selecting escape, going to normal, where you can see that is 60 degrees. And next comes is we want 37, which means 53 degrees with respect to y-axis, which is vertical axis. So we need to see the coordinates of this node point. It is 10.39, 2 and 6. And now we'll move this entire structure to minus 10.392 and minus 6. So you can see this is our origin. Now we edit and select 53 degrees. Since this is 37, we will have 53 degrees as this a here angle, and the vertical will be 90 degrees. So 53 degrees with respect to y-axis, and it will be positive 53 degrees. Select OK. Now you will draw, since we need 6 feet, or you can draw up to an end. Now select an escape, then select 0, select OK. Well, we need here 6 feet, so what we'll do is select this beam and select insert node, select distance 6, select OK, add new point, select OK. Now this is 6 feet, so what we'll do is, then we'll go to geometry, select add beam by perpendicular intersection. We'll select this node point and select this, so you can see a beam is created. Now we'll check this node point, move it to origin 10.392 and 8, select the entire structure, select right click, select move 10.392 and 8, select OK. So you can see the structure has moved, and but we need an extension beam here. So what we'll do is, once again we just need to check this 5.6 and 11.611. So you see, I have moved that point exactly to origin, so that I might extend that beam to some distance. Now coming again to this point and moving it to the origin 5.6 and 11.611. In this way we are done. We will intersect all the members so as to delete the unnecessary required beams, and now we can see that we have an 30 degrees with respect to x-axis an angle and a 37 degrees angle. Now we don't want this, sorry, this we need it. We doesn't require this. We need this, since we need an extension. Oh, no, we don't require that. Select delete. Now you can switch out the grid and see it is exactly as shown in the figure. However, then anything else required, we check. Well, there is nothing. You can see this is a cable and these are angles and these two are beams. So we go to general, select define, assign profile. First will be angle, second will be beam, then will be cable, assigning cable, then comes beam, we'll merge those beams, then comes assign angle. You can see the dimensions as exactly 6 feet, 4 feet and 8 feet as required. Now going to supports, you can see there is pinned support here as well as a pinned support here. So go to support, create pinned support. Then going to loads as shown in the figure, there are 10,000 and 8,000. Assigning both the loads to their necessary node points. Scaling the loads, going to design tab, assigning the commands as well as the code. Then analyzing. Well, checking first for failed beams. No failed beams, we can go to post processing and view the deflection as it occurs that way. Since we are completed with these two problems, we will be going for next set of problems, which will be these two. So we'll begin it. So here is the figure. So we'll draw it first, this one. So go to new, select new truss, give it a name, select units foot and pound, select next, select finish. Now just edit it to 20 by 20 grid. So let us see the figure. You can see there are three base of 6 feet. So let us draw them first. 6 feet, then 6 feet and then 6 feet. Now select escape. Now as you can see from here we have 53 degrees till exactly 6 meters horizontal distance. So go to edit, select 53. In x, with respect to x it is 53. As you can see it, with respect to x it is 53. So make sure you just draw it exactly above this node point, then select escape, then get back to the original grid. Now what you will do is you will draw a line like this. then intersect these members. Okay, then you can delete these members. So exactly we got up to this length at 53 degrees. Now coming to this, we'll send this node exactly to the origin. So we'll move it, move member x direction -18, select OK. Yes, yes, you can see it has moved. Now as per our figure, we have 53 degrees with respect to x, but with respect to y, it will be y direction, it will be 37 degrees, and which it will be positive. So edit 37 degrees, select OK. Now draw to a bigger length, then go back to the original and move the entire structure back to its original position. Okay, now you draw from here to here and just intersect these members in order to remove the extra members. Well, these are the extra members. Okay, now you can go to geometry, select add beam, point to point. You can select these 2 points, and later on, as you can see in the figure, we need a node exactly at the center of this beam, and it will be meeting at this end. So we select this beam, give right click, select insert node, select add midpoint, select OK. You can see it is exactly at a distance of 4. Now go to geometry, select add beam between point to point, select these 2. Now press escape, then you can switch off the grid, and as you can see, this is the exact figure what we are looking, except the down one is beam and the remaining are angles. Also there exists a node here of 5000 pounds load. So what we'll do is, and it's exactly at the center, okay, we'll just switch on the grid, and since 9 is the center, you can see, then now you select these members and intersect now delete the upper one and also the lower one. So you can see a node point is created exactly at the mid as we require. Now let us go to general, define angle and beam. Actually in the in the previous diagrams I did also mention circle, but I forgot to mention it as material as steel, so please get it corrected. Assign angle to the required beams, then beam to the beams. So you can see these two are got separated, so we merge them as per our figure. Now we go to support, create supports, which will be pinned support and pinned support. So we select exactly the 2 nodes we require, then go to loads, add nodal loads, where you can see there is 5,000, 4,000 and 10,000. So first one is minus 5,000 pounds, and next one is minus 4,000 and minus 10,000. Minus 4,000 and minus 10,000. Now you need to assign these loads to the particular nodes. After assigning, you scale the loads using this icon, as you can see. Then you go to design, select the ES code 800, give the commands check code and take off, and assign this to the selected beams or angle members. Now go to analysis, analyze, go to select by specification all failed beams. You can see there are no failed beams. Go to post processing to view the deflection occurrence. As you can see, the deflection does occur in this way. So now we go to the now going to next problem. We have this, so I can say this is 5 feet and this is 3 feet, so you can say this horizontal distance will be exactly 4 feet. So let us draw it. Go to new truss, foot and pounds, select next, okay, finish. So you can see exactly 4 meter distance and 3 meter downwards. And we need more, is 2 feet. So what we'll do is we'll just take this. Before that we'll check this node point, it's 4 and 1. So we'll move this structure exactly to the origin. Now that you have moved, you can say that we need 2 feet. So you can say that 3 by 5 or 4 by 5, it can be 37, 53 angles. So since this should be 37 and this should be 53, and this is 53, you can see this will be 90, and then this will be 37, which is minus 37. So you edit, select minus 37. As you can see, 2 feet we need, so we draw 2 feet, select escape, go to edit, remove the skew, and let us see the distances. So it got to 2.5 feet. So what we'll do is we will just insert a node at 2 feet. So you can see this is 2 feet now. We can delete this chunk and we need this point or else this point to be exactly on the y-axis. So let us see. Y is minus 1.2404. So we move this upwards, plus 1.204 initially. Let us move it plus 1.204. Select OK. So you can see now it is exactly on x-axis, but we need this point on exactly here y-axis. So let us check this point distance, which will be 4 along x. So we'll move 4, select the entire structure, give right click, select move, select plus 4, select OK. So exactly it has moved. Now you can switch off. You can see in the figure our diagram same as it is, except for this you can delete. Now you can switch off the grid. Coming, there are 2 pin supports and one 4000 pounds load, nodal load. You can see the dimensions. So go to general, select define angle, assign angle property to the entire structure, then go to support, create pinned support, assign this pinned support to the 2 nodes, then go to loads, nodal load, which is minus 4000 pounds, assign it to the node, scale it, then go to design, select the particular code, IS code, give 2 commands, check code and take off, assign those 2 commands to the entire structure. Now you can analyze it. Now first we go to select by specification or failed beams. There are no failed beams, so we'll see deflection now. As you can see, deflection occurs in this way. So this is the end of the steel trusses session. In next session we'll be seeing an RCC building with beams and columns of steel, and later on we'll be moving to advanced classes. Thank you. Subscribe to the channel. Most importantly, we forgot one thing, that a cable also consists of a tension. So let us see if we can find a a truss with a tension. So this is a truss with a tension. This includes a cable member with a tension. So you select the member, go to commands, select member specifications, select cable, then give the tension in the cable whatever provided, then assign it to the cable. Now you run analysis. Well, you can see by going to by specifications all cables, you can see this is a cable member. Now in this way tension in the cable as well as with this circle cross sectional area both are provided. So this is the end of the session. Thank you.